Welcome back, General Maths. And then today we're gonna keep doing the chapter two, investigating the data's distributions. And today we're gonna learn some percentage of data lying within the multiple standard deviations of means. So the first thing I want to talk about is the most important part is like understanding the standard deviation and what is the data distribution looks like. And also able to introduce the what's the 68%, 95%, and 99.7% rules about the bell-shaped data distribution. So first thing first, um, for standard deviation, so back on the first step is the means like measure the spread data distribution about the mean. So which is like standard deviation is defined the number of data values, the sample size, and the mean in between the values. Um, so 68% that data will be lying within the one standard deviation of mean. And what does that mean is like you only have one standard deviation of mean, so which is like I will show the graph anyway, and you will have a look the perfect sense. 95% of the data will align within the two standard deviations of mean, and 99.7% is the data will align within the three standard deviations of the mean. So, which like have a look. It's helpful to give the some like graph to have a look. So we have a smooth curve, like smooth curve, every single time if you write down the standard deviation. Um, you can say this going for like that way, and so you're going that way, and then the 68 data will be within the one standard deviation, which is uh mean minus one is the standard deviation, mean plus one, which is standard deviation on the other side, and mean in the between is this one. Yeah. And 2, which is mean and minus 2 and standard deviation, and mean plus 2, so which is 2 within. Yeah. And 99.7% of the data will be the plus 3, so which is you can say the curve is slightly getting flatter, but actually that means 99% of the people or population in between. Only 0.15% is on the top and bottom. So, for example, actually think about that way. If you have a ATA score for your final examinations, 99.7% of people had the mean is like 30 out of 50. Uh, and below the 30s will be like, for example, below the 30s will be like the mean like minus 3, so which is like only 0.15% people is below that meanings, and also above the like 0.15% people actually got the higher than the means. And if that makes sense, or maybe not, maybe using another way to say it. So how about this? Mean is in the between, so like 30. And then this part is like 49 out of 50. And this part is like only 10 out of 50. And rest of the people are in between. And that's how the populations if they going for the ATAs. Yeah, something like that. Um, okay, if that makes sense, we could do some like the examples. So the distribution of the examination scores a very large statewide examination, statewide. Uh, Approximately the symmetries of bell shaped. So this is the bell shaped, and the mean is 65, and standard deviation is 10. So, which means if you had one approximately what's percentage of the uh, students score from 55 to 75. So we know the mean is 65, right? So the score below 65 and which is 55 is your first standard deviation. And if the score above the 65 is 75. So which is this is above the standard deviation by 1 as well. So remember, standard deviation is 10. So below 10, so below 65 is 55 is below 10. That's your first part of the standard deviation. And the bell curve will be looks like that, like that. So this is 68%, and that's the first standard deviation. 55, that's 65 standard deviation, and that's mean 65. That's 75, by the way. Yep, there you go. So which means 68% of scores are between. Okay, so 68% of the score are between 55 to 75. Yeah. And second one, if this is 45 and 85, now your bell curve is a little bit different. So that'll be like, yeah, so your standard deviation, the score below below the 65 and by 20 points, so that is 45. And score above 65 by 20 is 85. So we can say your standard deviation become like 2 standard deviations because it's become like 20, right? So you're below 20 by 20, and then you above by 20, so that actually is become like 2 standard deviations. And that means 95 of the people in between the 45 and 85. 95% people are between. And last one will be 35 between 95. So there you go. Your standard deviation actually is the 3 standard deviation now. And your bell curve will be like that. So that's only a little bit in here and a little bit in here. So which is 99.7% in between. So does that make sense a little bit more? So that's how they actually say what's the standard deviation looks like, and then between the means, and then there you go. Another question was like something like you had your mean of the 5 millimeter standard deviation is 0.01 millimeter, and then we have to find out what's your A and B in between. So we can say the first one is approximately at 68%. So we could say it's plus 0.01. That's 5.01 millimeter. And 5 millimeter minus 0.01. So that's your standard deviation, first standard deviation, and then there you go, that becomes 4.99 millimeter. Yeah, if that's a 2 standard deviation, you have to become a little bit differently. So B, we can say approximately is the 2 is 95%, so which is like 2, so you have to be your C equal to 5 minus 2. Sorry, by the way, this one is B, this one is A. So C equal to 5 minus 2 times 0 0.01, that equal to 4.98. And D equal to 5 plus 2 times 0 0.01, that's 5.02. So you just keep doing that, like the standard deviation, and then you just keep adding and subtract the whole thing out. 5, so this one is E, so which is 5 minus 3 times 0 0.01, 97. F, 5 plus 3 times 0 0.01 equal to 5.03 millimeter. So there you go. That's basically to showing you how we're doing the standard deviation, and then what's the 3 standard deviation means, 2 standard deviation means, and 1 standard deviation means. Hopefully that makes sense. And then, yeah, next lesson we're gonna learn the box plot, which is the most important part, I reckon. And hopefully you guys understand what standard deviation looks like, and then we're gonna calculate during the CAS calculator as well. So hopefully you enjoyed it. I'll see you guys next time, and yeah.